Lab 11, Force and Acceleration Simulation with Vector Grid. First, I just illustrate what you actually do, and before you go to the lab and see the assignment. First, you start the field. You want to clear out all the vectors because I have the initial vector start here. So try to cancel this. For example, I think this is around 80 degrees. Just check, see if it's 80 degree. Then I add this over here, 100 in magnitude and 80 in angle. Boom. See, I know the direction. Now if you turn negative and then reduce. Now I keep on reducing 100, almost 0, and then now if I'm reducing more, it will be the other way. So, and then I added this back, and then I reduce it like 30. Okay, negative 80 direction. Everything is gone. So the first task is clear out the default vector. So I have to clean vector. If you figure out how to clean out the target first, target sees here. We are not going to use the target here, which is similar to different physics processes. First thing I want to do is simple, to simulate a linear acceleration of this object shoot out from blue. The Newton's first law says an object will keep constant regular motion if there's no force. Now if you shoot out this, and if you shoot from blue, and then it's just constantly moving, no acceleration, and shoot out again. So that's what Newton's first law says. An object will keep moving if there's no force. So if there's a force on it, that's Newton's second law, and then it will accelerate. Of course, the acceleration is in the direction of force. Once again, Newton's second law says the acceleration is in the direction of force. So we apply some force. To be in line with the balls that come out of this blue, I apply the force in 45 degree to all of along the path it passes. So which means all these diagonal squares. So first of all, I will add E. Well, I just as well add everything. 45 degree, 100. So that's E. Of course, that's 45. In fact, I should add 135. Okay, I take that back. Put a negative sign, so it will become back. So then I should be in 45 to accelerated blue, 135. So which means 135 degrees. So they will be here. Okay, so do you see if I shoot out the blue, it will, getting faster. So now I will add this 45 degree field, every field. So D, there, C, there, B, there, A, there you go. So constantly accelerating. So if you do this, then go. You see the ball getting faster and faster and faster. So that's now I will try a different field. Both accelerating, I want the blue accelerating less. So I reduce the field a little bit, still in 45 degree. I apply a little bit negative, which means I will apply this. So negative 100 was reduced, but I reduce a little bit. So 50, negative 50, watch. On the A, you see, smaller. And I will do the same thing on every field. So accelerating less. And then less. Then less. Okay, so which means the ball that shoot out of blue will start accelerating less. All right, let's go. Here, come out, getting faster and faster and faster. So that's accelerating. Watch. Okay, go. So it's accelerating less. And if you want even less, so you subtract a little more, I'm saying like 25. Small force. Okay, so now let's don't do 25. So I will want you to do 2 different levels. Blue accelerating, Save as. So blue accelerating. Two. Slow. Okay. Now let's try some deaccelerating, which means we're still shooting the blue. So but with the force, we will turn directions. So if you turn the force to the opposite direction, which means 25 degree, that will be deaccelerated. So then this is the deaccelerating. So now first I reduce the force. Force will be small, and then force will be smaller, 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 and smaller. So it will be deaccelerating. But then I keep on, so then of course this is still accelerating, and then you shoot, it's getting faster, so it's accelerating slower. Okay, so the force is proportional to how fast the speed is increased, or the Newton's second law says the force is proportional to the acceleration. So a smaller force accelerating slower. You see, now I reduce all the force to 0. So then C, all the forces to 0 and to 0. Now there's no force. So that's when Newton's first law says, okay, the object will stay in constant motion or at rest. It will be going in, no, so it's constant speed, never getting faster, never gets slowed down. Now let's try the other direction of the force. So the force should be against this. So then it should be negative 45 degree, but I will enter the other way. Negative 45 degree. I don't go negative 45 degree. I go 365 divided by minus 45, 315. Yeah, 315. So 3, or you can go to never 315. So 315. So then the force. So let's try 25. Okay, so let's on E. Watch. So little force against it. See, watch. You can see if you shoot out blue. Yeah, slow down a little bit, but you don't hardly notice. Okay, but if you apply to all of them at this direction, so little force, but against, so that deaccelerating. So B, deaccelerating, and deaccelerating. So this is like 25. So the force field go through this, but it's now you can see when the shoot out, the force is against it, kind of like a headwind, and slow down and slow down, slow down, but it's still going. So you see, faster, slow down. That's deacceleration. You know, there's the equation of motion we learned in the class that will take care of this. So slowing down, there's a little force, and then we increase the force. Now we increase the force by now it's 50, so bigger. But in fact, you only need to increase the diagonal line because increase the force. Okay, now so now you see, reduce the speed, reduce speed to 0. This is all like a gravity, right? And going back along this process, it's always there. So just go back to here. That's pretty interesting, but I don't know why it's shoot again. But should be, see, it's reduce the speed. So then you shoot. And so now deaccelerating is very interesting. So you see you have a little force coming out, and then slow down, and slow down to 0 and back. And try. See, slow down much faster. So it's, oh, you can even shoot it 2. Okay, and because it's slow down, you see, you can keep on shooting. It's all coming down back. You can keep on shooting more. So there's a force against it. So it's slow down over there. It can only shoot that far. Later on, we will learn the potential idea of a potential energy. It goes slow down because of the force against it. So it always slow down. Now, I will make the resisting force even stronger. So this and D and D and D and D. Stronger. So now if you shoot one, see it deaccelerating real fast. Okay, let's only go that far. But it's still going closer, right? You see? Closer. See that one, the first one shoot up to the middle, but this one shoot up to the second part, only third square. Now we're going to simulate a gravitational field, which means the force acceleration is all straight down, probably with 9.8 meter per second square. Not that, but we just simulate everywhere the object flying in will experience a force that's straight down. So we simulated a gravitational force by applying the force all straight down, which is 327 degrees. So now we will be applying the gravitational force on grade 5, for example. So 5. Now let me do small force first, but this time 270. Watch where it is. There we go. Little bit gravitational force. So then number 4. But in case you got that, you have to you make sure you're lucky you don't let this bump into the target, because we are trying to. So number 3, we're trying to simulate the field, but this target is sort of there to block our way. We probably number 3 and number 2. So 270, 25. So we again need to eliminate the number initial vectors. Number 1, let's see. So now this field is straight down. Okay, now go. See, it bends. Okay, but we need to eliminate the number column number 2. Now we basically eliminated the vector in column number 2 that came from the default. I'm going to add this back to the gravity. So it's 270 and 25. So add like that, but it's not quite. So then 25 more, and now negative 25. Negative 25. Negative 25. So it's gone. But there is something remainder. So let me just do 270. All right. Add wrong direction. I try to first reduce it to 0 first. Now it's almost 0 now. I'm going to add 270. Maybe 25. So down. So okay, that's good enough. So number 1. Now you see I have all these fields down. So shoot blue is like a gravity, and it bend. The acceleration is always downward, but now acceleration is not in the direction of the field. Velocity is where it goes, that direction, but acceleration vector is downward. Now I'm going to increase the gravity. So on this E column, so increase by 25, so bigger gravity. So on D column, bigger. On C, bigger. E, bigger gravity. Supposed to be uniform. I don't know, maybe that's one extra. Okay, on E maybe negative. Already 25. E maybe plus 15, plus 10. Oh no, plus 9. Yeah, I try to make it the same gravity. So let's see. Now you shoot blue, like So you see, look a lot like a parabola, like the tennis ball shooting. So the acceleration is always downwards. So then I would say the gravitation too. So everything. So now here is another one. Gravity field. Okay, I want you to do the same thing. Just play with it. I think you may be doing a better job. So the gravity field. Gravity 2. Okay, save it. Now I want stronger gravity and the D. So there. Stronger gravity is maybe on the Jupiter or some other. The gravity is stronger. So then you shoot something out. You see gravity is stronger. You go, boom. Oh, I shoot that. Okay, so gravity is stronger. Now, but let's do another game. For this one, this object is in the way, but I'm not doing a good job in this. But I wish you are lucky. Try to make sure this not go through any of the target. Now I add a 270 stronger gravity, but through another different setting. So stronger gravity. Now you see, shooting the blue. You see gravitation. Now you see that it's like a parabola. So that's how like gravity. So velocity is where the velocity is, but once the vertical direction, the velocity will reduce to 0 and go. But horizontal direction is always going at a constant speed. If you can trace it, goes in this direction is going with constant speed, but in the vertical direction it goes up and then goes down. Now I'm adding even stronger gravity, and C, D, E, so all down. So even stronger gravity. So the vertical direction, downward direction, but the shooting horizontal speed is the same. Vertical direction will be reduced to 0 real quick. Just watch. Boom. And then boom. But the other side, think about it. On the other side, the deceleration goes up and back. Up, back, back. Horizontal direction stay exactly the same. Horizontal direction stay the same. So go here. Right? Good. Now, very strong gravity. So you can try several of different strengths. Add gravity back. So now I'm shooting the blue. See, well, looks horizontal direction goes same speed, but the vertical direction will turn, see, much closer. Okay. All right. So that's it. So this familiar with you with magnitude and the direction, setting the vectors, correlating the numbers with the magnitude and the directions, angle, what actually look like, how strong it is, which direction it goes. And then you can think about it. Internally, it will add these vectors. If you add something, it will add this vector to the existing vector. We add vectors, and then you add vectors, you actually have to add components. So therefore, you will do a lot of exercise by converting magnitude and angle expression to the components direction. Basically, multiply the magnitude by the cosine of the angle. You get x components, and multiply with the y components. Getting in the y components by multiplying the magnitude by the sine of the angle. So that's why I want you to learn converting between the different representations. Internally is adding components, while your input, of course, you more visualized by using magnitude and directions.